difficult reading. A tank contains 400 litres of brine holding 100 kilograms of salt in solution. So there's 400 litres, and in that 400 litres there's 100 kilograms of salt. Okay. Water containing 1/8 kilogram of salt per litre flows into the tank at 12 litres per minute. Right? So every minute, if you do 12 over 8, because it's going to be 12 multiplied by 8 is going to be 12 over 8. It's going to be 1.5 kilograms of salt is going to enter this, and it's going to enter it per every 12 litres of water every minute. Okay, happy days. So there's a certain mixture of salt water, and then it's either diluted down or the concentration is increased. Right, so if you will, that's a quarter mass. 100 divided by 400 is a quarter, so a quarter of its weight. Sorry, for every 4 litres of solution there's 1 kilogram of salt. In this one, it's not as, this one is not as concentrated, so it's going to dilute down the original mixture. Not that we even need to know that, but just to know where I stand with the full question. Okay, now kept uniform stirring. So it's coming in and it's mixing and it's diluting the full system, and then it's flowing out at a rate of 12 litres per hour as well. So it's coming in at 12 litres per hour, and it's flowing, 12 litres per minute, and it's flowing out at 12 litres per minute. As a result, 1.5 kilograms of salt enters the tank each minute, and 0.03 kilograms are removed. So 0.03 kilograms of salt are removed. Okay, and it's represented by the function dq dt, where q denotes the number of kilograms of salt in the tank at the end of t minutes. Find the amount of salt in the tank at the end of 90 minutes. Alright, it's a fairly heavily worded question. Okay, let's start off with dq dt. It's an integration question after all, so imagine a little bit of integration wouldn't necessarily hurt us. So it's going to be, now this is a weird one here, right? So it's going to be, we just wrap all this up here. The t comes upwards, and that 1.5 over that, so it's going to be dq on the top, and it's going to be 1.5 minus 0.03 q equals dt. Now I'm just going to do a quick bit of revision on this, just in case we happen to forget. Okay, now if I integrate 1 over x plus 5 as an example, the answer for integrating this would be ln x plus 5. We'll out that. Now if there happens to be a 3 here, it'll be ln 3x plus 5, but then you have to divide by the derivative of the function, which will put it all over 3. This is no different. Alright, now it's not an x, it's a q, so it's minus 0.03 q plus 1.5. When you integrate that, and we will be integrating this, it's going to be ln, it's going to be all of this, 0.03 q plus 1.5, but then you're going to have to divide by the you're going to divide by the number that comes in front of the coefficient, which is minus 0.03. Awesome. Now, bad news for us. What are the limits? We have no limits currently, or do we? Let's find out. Well, when t is 0, that's 100. We know that much. Okay, so when t is 0, that's 100, and this must be q, and this must be t. Okay, so we integrate this, which we already have. It's from q. Oh, sorry. When we integrate this, it's from q to 100, and when we integrate this, which is just t, it's from t to 0. Now let's figure out what we can do with this. Alright, the first one stays the same. It's ln minus 0.03 q plus 1.5 all over minus 0.03, and this is t. Happy days. Cross multiply up to minus 0.03, so minus 0.03 t equals ln minus 0.03 q plus 1.5. Now please remember a bit about logs. If I said log, let me see, if I said log 100 base 10 equals 2, you would then say 100 equals 10 to the power of 2. If I said log base e x equals 3, I'd then say x equals e to the power 3. So using this logic, ln means log base e. Then I'm going to have e to the power minus 0.03 t equals minus 0.03 q plus 1.5. Is what we're hoping here. Okay, now what we're looking for is going to be 90 minutes worth. So the t value is going to be 90 in a second. So minus 0.03 q equals e to the power minus 0.03 t minus 1.5. And now I just have to find the q value when the e value is 90. So I'm going to get e to the power minus 0.03 times 90. So minus 0.03 times 90 is 22.7. So e to the power minus 2.7 minus 1.5 equals minus 0.03 q. So I'm going to put all this into the calculator here, and then I'm going to divide it by minus 0.03 and hope that it gives me a favourable q value. And we will find out now in a second. So put all that into the calculator and we get E. So what's it? E. I'm just using my regular calculator today, lads. 2.7, take away 1.5 all over minus 0.03. I got 47, so I think something is up once again. You gotta go and find it. Sorry lads, fairly obvious what I did wrong. See the 100, never used it. That's a very easy error. Sorry guys, never used the 100 up here. See the 100, glaringly obvious. So it's ln minus 1.03 q plus 1.5 all over my minus 0.03. Now what I'm going to do next is minus 0.03, and then it's take away the 100, so it's going to be 100, q is going to be 100, so it's going to be minus ln 100 times that is minus 3 plus 1.5 over 0.03, and all that equals t. And once again, if I give it a common denominator, then we end up back where we started, minus 0.03t. Now, what I'm going to do here is the minus 0.03's are gone. And what I'm going to do here is I'm going to do that's ln minus 1.5, I believe, and now ln minus 1.5. You can't have a log of a negative number, to my knowledge. No, log of a negative number does not work. So what did I do wrong this time? So log of a negative number doesn't work, which means my calculations aren't the best idea to begin with. And you wouldn't know that till now, that just happened. So that's not great. So something like this hits me, and once again I'm thinking on the fly here. I think I could have converted my system at the start, like so. Just go back to the, oh God love me, go back to the very beginning. And when you go back to the very beginning, and this is all done in the process, you're looking at that and you're going, okay, this, if I multiply, if I take out minus 1 and then I leave myself with 0.03q, take away 1.5 to t, and then I do exactly the same trick I did earlier, which is I leave the minus 1 where it is, so that's minus 1 to t, and then underneath here I have that's 0.03q minus 1.5 all over 1 to q, and then I integrate both sides from 100, that's 0, your t and your q. Then it's the same integral we did earlier, it's the ln one, so it's going to be ln can't believe this type of question, it's horrible question. It's going to be ln 0.03q minus 1.5 all over the all over whatever number comes in front of the variable, which is 0.03, and that will equal minus 1 t from t to 0. Okay, and this is from, so I don't make the same mistake I made earlier, q to 100. Now get this, it's going to be ln 0.03q minus 1.5 all over 0.03 minus ln. Now 100 times 3 is 3. 3 take away 1.5. All of a sudden this is a positive log, which is no problem. Oh, it's so annoying. Give them a common denominator of 0.03. So that's minus 0.03t. And then the 0.03's don't need to exist anymore. And then what I should get here is ln 0.0q minus 1.5 minus ln 1.5 equals minus 0.03t. I'm going to merge the two of them via the division rule. And once I merge them via the division rule, we're going to do the e thing again. So it's going to be all of this equals e to the power minus 0.03t, and all you have to do is isolate q. We don't even have to, we'll isolate q eventually. Minus 0q minus 1.5 equals 1.5 e to the minus 0.03t. Then I'm going to add on 1.5 and then divide it by, add on 1.5, that's 3t by the way, add on 1.5 and then divide it all by 0.03 to get my q value. And then we know that t value is 90, so t value up here is 90. Now we're going to throw all this into the calculator, and I said it's about 20 past 11 at night and I want to go to bed, so I'm hoping this better work. So we're hoping for 53.36, all going well. E to the minus 0.03 times 90. You should put this into your calculator now and see how it goes. And it is 53.36. Alright guys, hardest test ever, and you only ever get like those questions. He's taken like the hardest questions from the last 22 years and he's put them all into one test for some reason.